Now let's discuss about the product of vectors. So the first product is, so there exists two kind of product of vectors of two vectors. The first is dot product and second one is cross or vector product. So I will discuss first about dot product, then I will discuss about cross or vector product. So if you have two vectors A and B, their dot product is defined like the magnitude of A and magnitude of B times the angle between A and B. So the dot product is basically a scalar, since it has the resultant vector, let's say C, is dot product of A and B, small c, let's say A and B. This C has no direction, it is only magnitude, that is this. So if I have a vector A and B, and if they have angle theta, their dot product is defined like the formalism given here, mod A mod B cos theta. So the first application of dot product, one of the application of dot product in physics is, as you may aware of, is the work done by moving an object. That is, if the force is acting, let's say, along this direction, and you are moving an object along, let's say, this direction, along R, and with the angle theta with the force, then the work done against the force is F R cos theta, where R is basically the mod of R, that vector, and F is mod of F, that is F dot R. Okay, and by the way, the dot product of A and B is similar as dot product of B and A, that you can easily see from this formula. Since it's just a scalar, it does not matter. So this is the one of the application in physics, is work done. Now let us discuss about vector product or cross product. So if you have a vector, let's say this is A and this is B. The vector A and B is in the same plane of this paper, like so. If I define a vector C and A and B has an angle theta, so now if I define a vector C which is directed along the outward from the plane of the board, that is, let's say, if I denote the upward direction from the plane of this paper by this sign, so C is directed in this direction. So the thumb rule to obtain C is the following. So this is, you have a plane formed by A and B, and C will be directed here upward, because so let's the rule to obtain the direction of a cross product is if you take a right hand screw and if you swing the screw around from A to B, the direction in which the screw moves defines the direction of the resultant vector product. So now let's define a vector, and if we denote the direction of that resultant vector C, that is outward from the plane of the board, and the direction in this direction we define a unit vector eta from the which is directed towards upward, that is outward from the plane of the board. Then the cross product C is defined like, that is denoted by A cross B. By the way, the cross product is a vector because it has magnitude as well as direction. So the cross product is defined like A B sine and sine, then theta is the angle between A and B, and the direction in which the resultant directs, that is, let's say eta. Here eta is basically the outward from the plane of the board of the paper. So this is defined like this. Now let's take what is the cross product. Let us discuss what is the cross product of the reverse thing, that is B cross A. So if you take a screw, now for that you need to take a screw, right hand screw, then you need to swing the screw now from B to A, that is this, and you will see the screw will move inward and inward to the plane of the board, that is, but the screw has inward from the inward to the plane of the board, that is this vector B cross A has negative direction of A cross B. But what about the magnitude of B cross A? The magnitude of B cross A is basically B A sine theta. That angle will not change. That is the same as magnitude of A cross B. But this B cross A is directed along minus eta cap, and A cross B is directed along eta cap. So that's why we can conclude that B cross A is negative of A cross B. but in case of dot product, this B cross A, B dot A is same as A dot B. Now what is A dot dot product with itself? That is mod of A, and what is the angle between A with itself? That is 0 degree. So cos 0. So what is cos 0? It is just 1. So it is basically that is mod of A square. Now if you take that A, if you take the unit vector instead of normal vector, you will basically get 1. Now what about the cross product of A with itself? So the cross product, the magnitude of this cross product, if you define, then it is just mod of A, then sine angle between A with itself, that is 0 degree, but sine 0 you already know is 0. So it's just the inner cross product of A with itself is 0. So this 0 vector is still a vector. The direction can be chosen in this case along the direction of A. So it's still a vector. 0 is still a vector. So let's sort from A dot product with itself, cross product with itself is 0. Now the dot product of A and B can also be represented as the A times projection of B on A, or B the magnitude of B times projection of A on B. So how do we prove this? So let's say we have vector A and B. If you take the projection of B on A, here this is the projection of B on A. That projection vector, if the angle between them two vector is theta, so that projection vector is basically B cos theta. So what is the dot product of A and B? Is A B cos theta. That is mod of A times this projection of B on A. So how do we prove this? In order to prove this, if I have vector B and if let's say you have vector A, in order to take the projection, you need to extend that line and draw a perpendicular here. So this is the projection of A on B. So what is the length of this projection? The length of this projection is A cos theta. This is the right angle triangle, and this is A cos theta. So that is A dot B is B A cos theta, we already know. That is B times projection of A on B. So in this way you can say represent the scalar product as projection. Now okay, So the example of cross product in physics. The first example is a torque, which is defined like this R cross F. So what is a torque? Torque is basically the rotational effect of force. So for a body, that is, let's say you have, so the torque is basically the rotation version of the force. So for a, let's say this object, the stake, let's say you have a stake and it is attached to the one end of the wall, and if you make it horizontal, then leave the stake, then it will move in this direction. So why, the question is why it is moving? It is moving because we have the force of gravity, that is mg, acting on that stick, that is with the from the center of mass, let's say. Then if the direction of center of mass is, let's say, r, the position vector of center of mass is r, the torque acting on it is basically torque acting on it F cross, torque acting on the stick is R cross F, that is mg r. And what is the direction of the torque? The direction of the torque is here, it is in, so the force is acting, the R is acted here in this direction, and the force of gravity in this direction. So the torque is directed with the R cross F. It will be, if you take the R and F, direction of F, if you take the R and F to be in the plane of this paper, then that R cross F will be directed in the downward direction, right? So the if you assume that downward direction to be eta, then this is just mgr eta. This is the unit vector. So the torque acting on this stick, it causes rotation. So the rotation of this stick, that is, after a certain time it will move here, then it will move here, ultimately it will stabilize when it is in the vertical direction. At that direction, in this direction, the torque acting, why it will, the question is why it will stabilize when the stick comes in the vertical direction. It will stabilize because at that moment the torque acting on the stick is 0, because the position vector and the force of gravity is in the same direction. That's why the cross product of between these two forces is 0. That is, in the other word, that is torque is 0. So that's why the stick will stabilize. So the reason for the rotational motion is the torque, that is the rotational version of force. So this is the thing. Now another example of cross product is the area vector. So if you have two vectors A and B and you complete a parallelogram of with A and B, now if I ask you what is the area formed by the vector A and B, so the magnitude of area, that is, let's say S is the area of this parallelogram, the magnitude of this area is this base times height, h. And what is h? H is b sine theta. So that is the area is this base times height. So base is mod of A and height is mod of B sine theta. So if we define the direction of area to be along the cross product of A and B, here we are representing area as vector such that it is directed along the cross product of A and B. In this case, that is outward from the plane of this paper. Then this area vector S is defined like A cross B from this relation.